Hey guys, Mr. Patterson here, checking in with another vectors video for IB Math AAHL. We're going to look at the angle between two vectors. So this is the part where the vectors start to get a little bit fun, a little bit interesting here. We're going to look at vectors and we're going to look at the angle between them. And before we get into what the rule actually is, we're going to revisit an idea that we've talked a lot about this year, and that's the law of cosine. If I were to look at this vector A and this vector B, and I'm trying to be concerned with this angle here in between, the law of cosines says that the magnitude of B minus A squared, now think about that, B minus A squared. So I'm doing minus A plus B because that's the same as this green vector here. And that vector squared is equal to vector A squared, its magnitude, the magnitude of B squared minus 2 times the magnitude of A times the magnitude of B times the cosine of that angle there in between. Now, from that, if we think about vectors A and B, and let's just call them here, vector A has a component form of A1, A2, A3, and vector B is B1, B2, B3, then B minus A, the vector B minus the vector A, is B1 minus A1, B2 minus A2, etc. And then from there, we can do a substitution, which allows us to say that A dot B, in other words, vector A dot vector B, the dot product of them, is equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle between. So through the analysis of the cosine rule, we get ourselves here this formula for the angle between two vectors. Now, once we have this formula here, which is in the formula book, by the way, we can use it to solve for different things. So let's take a look at a couple of problems here. First of all, we could rework the equation to solve for the cosine of that angle between, and say the cosine of the angle between is equal to vector A dot vector B divided by the magnitude of vector A times the magnitude of vector B. So if vector P is 2, 3, -1, and vector Q is -1, 0, 2, and I'm asked to find the angle between P and Q, well, I can start off by finding the vector P dot vector Q. That's just -4. And then I can use the angle between vectors formula to say that the cosine of that angle is equal to vector P dot vector Q, which we already just found is -4, divided by the product of the vectors, which is going to be 2 squared plus 3 squared plus 1 squared, square rooted, times the square root of 1 squared plus 0 squared plus 2 squared. That gives me -4 over root 70. And then if I'm looking for the angle itself, I'm going to take the inverse cosine of -4 over root 70, and I get about 119 degrees. At this point, we're not super concerned with whether we're talking about the angle measured in degrees or radians, so either one is acceptable. Let's take a look at some more properties here. It says using the formula vector A dot vector B is equal to the magnitude of vector A times the magnitude of vector B cosine of theta. We notice that if A is perpendicular to B, then obviously theta is equal to 90, and therefore A dot B, vector A dot vector B, we know the cosine of 90 degrees is 0, so therefore the scalar product is 0. So if we have a scalar product that is 0, that means that the vectors are perpendicular to each other. Similarly, if the vectors are parallel, well, if they're parallel, the angle between them is 0, or possibly 180 if they're going in opposite directions. Whether I'm talking about cosine of 0 or cosine of 180, cosine of 0 is 1 and cosine of 180 is -1. Therefore, if I have A dot B, in other words, the scalar product of vector A and vector B, and that is equal to the plus or minus magnitude of vector A times the magnitude of vector B, then I have parallel vectors. All right. Therefore, we can come up with these properties here. If A dot B is 0, if and only if vector A and vector B are perpendicular, and if the magnitude of vector A times vector B is equal to the magnitude of vector A times the magnitude of vector B, then A and B are parallel vectors. Then it says here in number 3, if theta is the angle between vectors A and vector B, then A dot B is equal to the magnitude of vector A times the magnitude of vector B cosine of theta. And if the angle is acute, then we know the cosine is positive because it's in the first quadrant. And if it is obtuse, the cosine is negative, and therefore A dot B is negative. And the reason it's negative because we'd be in the second quadrant there if the angle is obtuse. Let's take a look at this example. Example 30, it says find a vector of length 3 units, which is perpendicular to negative 1, 4. So we start off with the idea that it's got to be perpendicular. And if it's perpendicular, that means the dot product is 0. So we have negative 1, 4. Negative 1, 4 times what is going to give me, is going to give me 0. Negative 1, 4 times 4, 1 gives me a dot product of 0. Therefore, 4, 1 is what's referred to as the direction vector. And then we want to figure out what makes that magnitude of 3. So in other words, if we do k times the vector 4, 1, we want that vector to be 3 units long. Well, currently, 4, 1 has a magnitude of 17. So therefore, if I want it to be 3 units long, I'm going to multiply that vector 4, 1 times 3 over root 17. And I could leave it as 3 over root 17 times the vector 4 over 1. Or I could distribute that and end up writing this answer here, 12 over root 17, 3 over root 17. I don't have to distribute, but I can. Let's take a look at one more example. It says vector A and vector B have lengths 5 units and root 7 units respectively. So therefore, vector A is 5 units and vector B is root 7 units. And the angle between them is 110 degrees. It says find A dot B, vector A dot vector B. All right, so we have a lot of information here. What we don't have is the scalar product. But the scalar product is equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle between them. So I have 5 times root 7 times the cosine of 110 degrees, all of which was given to us. And we end up getting the scalar product is equal to about negative 4.525. One more example here. It says use vector methods to determine the measure of of angle ABC. So here's A, here's B, and here's C. Oops, C is in the middle here. So A, B, C. So I'm going to have to use quite a bit of knowledge about trigonometry in order to help us out here. But if I think about what's going on here, it's really just an application of these vectors here. So if I put it onto a coordinate plane, all right, if I put it onto a coordinate plane, notice the height is 3, the depth is 2, and the width here is 4. If I go ahead and I put this onto a coordinate plane where I have 0, 0, 0 in this back corner here, I don't have to put it there, but that's just the way I chose to do it. That makes vector BA 2, negative 4, negative 3. BA, right? And then vector BC is 1, 0, negative 3. Okay, so BC, all right? So if I have these vectors here, okay, then I'm going to be able to find the angle, the cosine of that angle is equal to the scalar product of BA and BC. Notice that they share that vertex B, which is what allows us to be talking about the cosine of ABC. And I'm going to divide that by the magnitude of vector BA times the magnitude of vector BC. And once I do that, then it's just straightforward plugging into the formula. I end up getting that the cosine is equal to 11 over root 290. And then I just take the inverse cosine of that, and I get about 49.8 degrees. All right, that's it for this lesson here. I'd like you guys to work on page 303, numbers 3 to 21 by 3s. Let me know if any of them caused you any trouble, and I can make a separate video to help you understand them. Have a great day, and I'll talk to you all soon.